In this video, we're going to work on solving for variables in a different type of an equation. As you can see down below here, I have Einstein's famous E equals mc squared equation. What we're going to be doing in this video is looking at equations and deciding, you know what, I don't want to have E equal something. I want it to be M equals. So we're going to be working on rearranging our formulas to solve for whichever variable we want to try to solve for. It could be M in this case, or it could be C in this case. Either way, we are going to be working on solving for specific variables in equations that have more than one variable. With that said, let's jump into our first example. For our first example, we have here d equals rt. This is a type of distance formula where d stands for distance, r stands for rate of speed, and t stands for time. Well, right now we are solved for d. When we say we're solved for d, it means we have d equaling the rest of it. Our goal for this first example is to solve for r. So we want not d, but r. And if we've watched the other videos on how to solve equations, we should know that inverse operations are going to be a huge part of this. So the first thing we want to do is identify the variable we want to solve for. We want to solve for r. The second thing we want to do is identify any operations that r is a part of. So as we can see here, r is being multiplied by t, and that gives us distance. Well, if I want r to be by itself, if I want r to be on the other side of the equal sign all alone, I'm going to have to get rid of this t. And we are going to do that through division. So in order to isolate r and to undo the multiplication between r and t, we need to divide both sides of our equation by t. T divided by t on the right side is 1. So those cancel out and we're left with r. On the left side, let me get rid of this because this is just getting in the way. On the left side, we have d divided by t. And now r is all by herself. So we can say that in this formula, if we were to solve for r, r is the distance divided by the time, or r equals d over t. And we will just leave it like this. We solved for r. We got r alone, and that is exactly what we were hoping to do. If I wanted to, say, solve for t, here's our equation again, d equals rt. Well, we'd go through the same steps. First, identify the variable we want. That's t. Identify any operations that are being performed on t. Well, r is multiplying by t. So if I want to get t all by itself, I need to isolate it from that r. So I can divide both sides of the equation by r to cancel it out. And we're left with t equaling d over r. So we've just transformed this equation, this formula, twice. We now have 3 equivalent formulas. We have r equals distance over time. We have time equals distance over the rate of speed. And we have our original equation of d, or distance, equals rate of speed times time. So this is a pretty handy trick if we can use this on formulas. They won't always be this simple, but it's always nice that if we're trying to solve for a specific variable, we can rearrange our equations. Here, we would want to use this variable if we know the rate of speed and the time, and we're looking for the distance. Here, we can solve for the rate of speed if we know the distance, and we know the time. And lastly, we can solve for time if we know the distance and the rate of speed. All right, let's take a look at a different, maybe a little more complicated formula and see what we can do with it. Here we have maybe a little more complicated formula. We have m minus n equals 5. And as this equation or this formula stands, we can't solve for either m or n. We don't have enough information. But if we want to solve the equation so that it is equal to m or equal to n, we can most definitely do that. Let's say we want to solve it so that it is equal to m. Well, I've identified my variable first. I want the m. Now look for any operations that are being performed on the m. And we should be able to see, oh, I am subtracting n from it. So if I want to isolate m, I have to get rid of the minus n. And to do that, I will add n to both sides. Those get canceled away, and we have m equals 5 plus n. And there we have it. We've now solved this equation for m. So whatever m is, it's the sum of 5 and n. Pretty handy. Now let's say we have that original equation again, m minus n equals 5, and this time I want to solve for n. Well, I'm going to have to perform two different steps. I'm going to have to get m out of the picture so that m is on the other side, or I'm going to have to get n over to the other side and then get rid of the 5. And that's going to be the way that I'm going to choose to do so that I don't have to worry about multiplying or dividing by a negative 1. So I'm going to add n to both sides, just like before. So I have m equals 5 plus n, but now I'm going to get rid of the 5, so minus 5 from both sides. And I subtract 5 because this 5 is positive. So if I want to bring it down to 0, I'm going to have to subtract it. So the 5's cancel out, and we have m minus 5 equals n. So whatever n is, it's 5 less than m. So we've just taken this equation and created three different versions. We have our original version, m minus n equals 5. This was our first version. Then we solved for m. So we had m equals 5 plus n. And then we solved for n. And m minus 5 equals n. So hopefully we're starting to get the hang of this. But I have one more doozy of a problem for us. If you can handle this one, you can handle pretty much any of these. In front of you, you see f equals 9/5 c plus 32. This formula, which looks kind of ugly as it is, this is the formula to change something from Celsius into Fahrenheit. Whatever the Celsius temperature is, you multiply it by 9/5, and then you add 32 to it. That's the formula. But we want to know what the opposite would be. We want to solve for c. So we don't want to have f equals all of this. We want to have it be c equals something. So we have to take a look. We know we want c. There's our variable that we want to solve for. But what operations are being performed on c so that we can undo them? So I would say if you want to give this a shot, pause the video. See if you can handle solving for c. See what you come up with, and then when you're ready, unpause the video and see if you're right. Alright, so I want to solve for c. c is being multiplied by 9/5, and then having 32 added to it. So if I want to solve for c, we can treat this as if it was one of our two-step equations and first get rid of our constant. So I'm going to subtract 32 from both sides. That'll cancel out 32 on the side with c and move it over to the side with f. So here we have f minus 32 equals 9/5 c. Now, I still want to get c all by itself. To do that, I'm going to have to get rid of 9/5. Now, there's a couple different ways we could do this, but the easiest way is to multiply both sides by the reciprocal of 9/5. So the reciprocal would mean flipping the fraction, and we're going to have 5 over 9 being multiplied on, whoops, that should be a 5, being multiplied on both sides. Now, one thing you need to be careful of, you're multiplying this entire side by 5/9. Sorry, there it is, 5/9. So if you write it the way that I've written it, you run the risk of only multiplying the f by 5/9. So we're going to want to put parentheses around the f minus 32. That way, we know this 5/9 is being applied to both pieces, not just one of them. So, when we multiply 9/5 by 5/9, these cancel out, and we're going to be left with c. That's what we wanted. C all by itself. Now, we have to take a look at this side. On the left side, we have right now 5/9 times f minus 32. And we actually want to leave it just like that. The reason being, if I were to distribute 5/9 into our parentheses, we'd have 5/9 f, which is okay, but 32 and 5/9 don't get along very well. So we're not going to have a nice number. We're going to have a difficult fraction to work with. So we can just leave this as this. So now, if we have a degree in Fahrenheit, and we want to find out what the equivalent temperature in Celsius is, we can use this formula. So there we have it, solving for specific variables. Your 3 steps to solve them are: 1, identify the variable you want to solve for; 2, identify any operations being performed on that variable that you will have to undo; and 3, use inverse operations to isolate the variable and solve for it. Hopefully you found this video helpful. Good luck.